Hello students, welcome to Arjun My Classes. Today we will solve one more problem on the graphical method, and previously we solved problems on maximization. Today what we'll do is we'll solve the problem on minimization from the graphical method. So this is a problem. Here he is asking us to identify the optimal solution and identify the feasible reason for this problem, and this problem is subjected to the minimization. Okay, so now here he is giving an objective function z equal to 20x1 plus 10x2, and he is having the three constant equations x1 plus 2x2 less than or equal to 40, and another one is 3x1 plus x2 greater than equal to 30, 4x1 plus 3x2 greater than equal to 60, and he also given the non-negativity condition. So we already know the process how to solve this graphical method. Same thing here also. So we'll need to convert the equations into the inequality equations into the equal equations by converting them into the we have to convert them to the equal equations by replacing the symbols. Whatever the less than equal to greater than equal to symbols we have, we just need to replace that by equal to symbol. So what I will do, I'll go for the first equation here. The first equation is given x1 plus 2x2 is equal to 40. So then I have to identify the coordinates. The procedure is same what we done for the previous maximization problems. Same thing here. What I will do is I'll put x1 as a 0, and x2 is going to become 20, and similarly I'll put x2 as a 0, and x1 is going to become 40. So this is a coordinate for the first equation, and similarly for the second one, 3x1 plus x2 is equal to 30. So here it is given to equation here, same process. Put x1 is equal to 0, then x2 is going to become 30, and put x2 is equal to 0, then x1 is going to become 10. So for the third equation, so we'll go for this one, 4x1 plus 3x2 is equal to 60, and again x1 equal to 0, then x2 is going to become 3 2s are nothing but 320, nothing but x2 is going to become 20. So then x2 as a 0, we are going to put in x2 as a 0, then x1 is going to become 4 15s are 16 by 4, 4 1s are 4 1s are 4 15s are 4 15s, it is nothing but the value is x2 value, x1 value is 15. So now we got all the coordinates. So what we have to do is we have to plot the graph by using all these coordinates. Graph representation here. You can see this, the equation was given, and it is subjected to what? The equation is subjected to the, this objective function is subjected to the minimization, z equal to this one, and we already got the coordinates for the first constant equation, and x1 was 0, x2 value was 20, when x2 is 0, x1 value was 40. So then for this we will plot, when x1 was 0, the x2 is 20 for the first one. For the second equation, when x2 when is the same thing, so when x2 is 0, when x2 is 0, x1 value was 40. The first equation constants, so we represented both the coordinates here, and we'll join these two. And this I will call it as a 1. Okay, first equation. Similarly, I'll go for the second equation here. In the second equation, I will change the color here. Okay, second equation, it is saying that 3x1 plus x2 is equal to 30. x1 x, that time the coordinates are, when x1 is 0, x2 value was 30. For the second one, when x1 was 0, x2 value was 30, and when x2 is 0, x1 value was 10. We'll join these two now. Right, so again what I will do, I will change this color for understanding purpose. So I'll take other one. So for the third equation, you can say this, 4x1 plus 3x2 is equal to 60, and this, when x1 is 0, x2 value was 20. Same thing here again, and when x2 is 0, x1 value is 15. So we will join these two now. Okay, so now what we plotted all the three equations in the graph. So next work is what we have to identify the feasible region boundary where exactly the maximum optimal solution is located. So in that reason I have to locate first. To locate this, we just need to go for the conditions here. What are the conditions over here they given? Based on that, we can plot this one, right? So here he given less than equal to, less than is equal to means the feasible region will be the below the line. Whenever it is given less than or equal, so then feasible region located below the line. So whenever they given the greater than equal to, so then feasible region will be located above the line. Similarly for the third one, the feasible region will be located above the line, right? So from this we have to plot now. So first equation was this one, so feasible region will be below the line, so I will plot this. This is the below the line for this. For the second equation, it is above the line. Second equation is above the line, so this is the second equation, it is above the line. So you can say this, it is the line, in this it is above the line, means in between this it should come, because for the first equation it is below the line, and for the second equation is it is above the line. Next one is third one, 4x1 plus 3x2. So here it is again greater than, so then again for the third line it should be above the line. This is again it should be above the line. So then we identify the feasible region, and it should satisfy all the three lines here, all the three conditions. So for all the three conditions satisfied means, so this is our feasible region. This region is going to satisfy all the condition. I will hash this one. This is called as a feasible region. So now what we got here, here we got the region, and again here we got coordinates also. You can say this. So these points where the intersection is happened, these are going to become our corners. So then what I will do, I will take the boundaries, I will name them the initial boundary as a, and second one as a b, and third boundary I will call it as a c, and fourth one I will call it as a d. So now I have a b c d. So for that I will represent the coordinates. So for this a value, the coordinates are, for a corner the coordinates are what? So it is x along x-axis, so it is having 15 comma 0. For the b it is 40 comma 0. For c we just see this, so plot perpendicular line to this one. So once we plot this perpendicular line, so we are going to, here we are going to get the exact position here. So the exact position along the x-axis is nearly it is 4.5. I will take this as x1 as a 4.5, and x2 here whatever we have here, so for this it is around 18. Okay, so for the d value also, for the d corner, so here this x2 d corner is located exactly at the center, nothing but x2 is going to become 12.5 here, and you just plot perpendicular to this, so here it is going to become 5 comma 12.5. So here what we are doing is, here we are not using the graph, so we are just making the plot like that, graph kind of thing. But when you go to the graph you will get exact values, here we'll get some approximation values. Okay, so now what we done, we got all values for all the four corners. Next what we have to do is, we need to substitute the values in our objective function. So objective function is this one, 20 into 15, it is nothing but 300. So ZA is having a value of 300, and ZB, so optimal solution at the corner B, it is having around 40 into 20, it is nothing but a 800. And the ZC, you can take the corner at point C, 20 into 4.5 plus 18 into 10, 10 into 18. So 20 into 4.5, nothing but it is 900. It is not 900, it is 20 into x2, it is 90. 90 and plus 10 into 18, it is 180. So then value is going to become 280. 270. ZC is 270, and the corner at D corner, the optimal solution at the corner D is having value of 20 into 5 plus 12.5 into 10. So then this value is going to become, so here I will write 20 into 5, it is 100 plus 125. 100 plus 125, this is going to become 225. So here the problem is subjected to what? It is subjected to the minimization. So then what we have to do is, in this we have to take a minimal optimal solution. Minimal optimal solution we have to take. So in all these four corners, which one is giving minimum value, that we have to select. You can say this. So this is giving 270, the sector B is giving 800, A is giving 300, D is giving 225. Means the D is the minimum value. So then ZD, this D corner is having minimum optimal value here. So then I will write Z value as a Z minimum is equal to ZD, and the value is how much? 225. So then coordinates for this one, x1 is 5 and x2 is 12.5. So this is the answer for this minimization problem. Thank you.